Oh,
okay,
yeah,
so
that's right.
there are two kind of interesting sets of numbers that are pretty easy to calculate recursively. Pascal's triangle is one. The Fibonacci numbers is another. So I'm going to go through how to calculate some Fibonacci numbers. So the way Fibonacci numbers work are you start with 1 and 1. Okay? And then the next number in the sequence is going to be you add the previous two numbers together. So what's the third number? 2?
3.
And then you add those two, so you get 3. And then you add these two, so you get 5. And then you add these two, so you get 8. And then you add these two, and you get 13. And then you add these two, and you get 21. And then you do this for a while, right? And then somebody says, hey dude, did you know that if you take some pair of Fibonacci numbers, right? So I'm going to call, no, that one's too far out to count. I'm going to call this one here. I'm going to call that F5. Why would I call it F5? Because it's the 5th Fibonacci number, right? So this one here is F8. Right, because it's the 8th Fibonacci number. So what's F1? 1. And F2 is?
1.
Also 1. Oh shit. And this is a computer science class, so what should I do?
Code it.
I should code it, but first, before I code things, where do computer scientists start counting?
0.
0. So adjust your labels down by 1. Cool. And then there's a cool thing, which is if you take Fn, right, which is going to be someplace out here, and Fn minus 1, and divide them, there's a neat thing, which is that this goes somewhere interesting. It goes to a number called a golden ratio. Which is kind of a thing about aesthetics. Like pleasing to the eye things. So you think about kind of the, like, the nicest shape for a rectangle, right? Like, is this my best rectangle? Like, does that one make you the happiest? When you see a picture framed in this, you think to yourself, that's a little weird, right? You guys with me on that? This one? Even worse. Like, ew, right? There's one that looks something like, it's not quite this,
Very nice.
but it's a bit closer. You guys see that? Like in your mind, there's like a rectangle that's the right one. That right rectangle is 1 on this side and the golden ratio on the other side. You guys see that?
Does the 1 not change?
It's one of whatever these is, and then golden ratio of whatever the other one is. So if this is a foot, then this is the golden ratio feet. If this is a meter, then this is golden ratio meters. If this is 2 feet, then this would be 2 times the golden ratio feet.
Well, 8 and 5 is 1.6.
Yeah, so it's probably about 60%, right? You guys see that? Okay, I think we can figure out a better approximation for the golden ratio by figuring out a bunch more Fibonacci numbers, right? So let's figure out a way to make Fibonacci numbers. So last time I learned that I should pseudocode more and try to hack and bash less. Okay? So I want to write some code to make Fibonacci numbers. How could I do this?
We want to start with just the void function that's going to be doing
Okay, so first I should probably pick a language that I'm intending to do this in. I'm going to do this one in Python. But your pseudocode should be basically the same. Right? So what's your pseudocode going to be? To make Fibonacci numbers, you should okay, so you're going to need some integer variable types, right?
The golden ratio is a float.
The golden ratio will be a float, right? So my approximation for the golden ratio will be a float. So I think my variables, right? I'll need a float for the golden ratio, which I'm going to call golden ratio, because that's how I roll. And then I'm going to need some integers, right?
Integer A, integer B, because we're always going to be calling two of them.
Okay, so I really only care about the last two, right?
Right.
So I'm going to have like an integer. What are you going to call?
Fn plus 1.
Oh, that seems like a good idea. Let's call them f and, right? And another integer that's going to be f.
I think n plus 1 is going to cause problems.
Yeah.
Yeah, so don't do this, right? Like this is a bad name for a variable, right? N plus 1 with a plus and a 1 is a terrible choice. But you could do NP1 spelled out, right, for n plus 1. Or you could write n plus 1.
I make it really confusing by having my first one be f of lowercase n, and the second one is f of uppercase n.
I would avoid that.
Why?
Avoid that. That's
Story
gonna go
before I say
badly.
that.
I'm gonna do this. This is kind of a crappy naming convention, but this is the one I'm gonna pick. What else you got? So where do I want to output these?
And a print one?
Yeah, let's just print them out, right? So we'll just have it print them out. Okay. So, how do I print these out? What do I want to do? I think I need one more, right?
You need whatever is the combination of those two.
Yeah, I need the kind of next one, right? So I've got,
Wouldn't that be the golden ratio?
No,
that's the ratio between two. I want the next Fibonacci number, right? So how do you get the next Fibonacci number if you know two?
Add them together.
Add them together, right? So you're going to need an integer that's going to be f, and I'm going to call that one new, right? You guys with me on this? What's f new going to be?
Fn plus Fn P1.
That's going to be fn plus fn p1. You guys with me? And then what do I want to do?
Make a freaking void with the two numbers in, add them together, make new numbers, fall on itself. Something along those lines.
Okay. All right, so I think I want this to print at some point, right? Where do I want this to print?
Where?
I mean, I don't really care. I just want it to print, but where do I want it to print? Like at what stage in this process?
At the end?
At the end.
Or it does the maths.
Okay, so my next step should be something like print f new, right? You guys see this?
Are we looking for
And at this point, my pseudocode has gotten really disorganized. You guys all see that?
Yeah.
Because why? What have I mixed up here?
Variables in code.
Yeah, I mixed up, like, I was setting some variables, right? Like, this is setting variables. And then this is me doing stuff, right? You guys see that? Okay, so all right, I kind of want procedure here, right? Okay, so I think this is going to go through, right now this is going to happen once, right?
Do we want to print F new or do we want to print golden ratio?
Good question. Did I compute the golden ratio yet?
Actually, I haven't done it.
No.
Yeah, I haven't actually done anything with it. So I probably should put that into my do things, right? So that should be where?
Procedure.
That should be in here someplace. So there should be a compute golden ratio in there somewhere. Right? Okay, and then I print the new Fibonacci number. Maybe what else should I print? The golden ratio. Okay.
Also want to make another Fibonacci taking in F in P1 and F mu, and that's going to be the new F in P1. Do it again.
Yeah, so now you want to kind of reset and then loop through this, right? You guys see that? So my reset is going to be, what did you say, Story?
It's going to take in F in P1 and F new. F in P1 is going to be the new F in, and F new is going to be the new F in P1.
Okay, so you set Fn to whatever Fn plus 1 was, right? In other words, you're going along a step, right? So the left end, right, is now going to be the thing that was in the middle before. And then Fnp1 should be F new. You guys see that? And then what?
And then do Fibonacci number.
Yeah, and then loop through procedure. You guys see this? Okay, so since am I out of time? I'm out of time. So since I'm out of time, your assignment is get this working in Python or processing. I don't care which. Right? And I would like you to note that you need to get this to stop sometime. You guys see that? Like, you're going to have to find some reasonable stopping condition on this. Cool?